This is AB Calculus Note Card 57, Use Substitution. This is the 57th video lesson in the series inspired by Stacy McMullen, formerly of Dowson Independent School District, who developed the note card system. The use substitution rule is, in a way, analogous to the chain rule in differential calculus, in that you apply this rule when you have a composition of a function, and we're going to get into what that is. And here are the rules. We're going to be looking for letting u being an inner function, and that would be, well, we're going to give examples. And then what you do is you take the derivative of both sides and you substitute in, and then you integrate and then substitute the original function back for u. And we're going to see a few examples of this here. Examples show better what this is. So if we have dy dx equals cosine of quantity 2x, then y equals question mark. And here we have a situation where we don't have a simple single variable like x. It's the cosine of 2x. And so in use substitution, what we're going to do is say let u equal 2x. So I'm going to come over to the right and say u is equal to 2x. And then taking the derivative of both sides, we have du is equal to 2 dx. And since in the original function we're going to have to solve for dx, if we divide by 2, dx is equal to du over 2. Okay, let's go ahead with this problem here. If we have dy dx equals cosine 2x, we can work toward making a y-equal equation by multiplying both sides of the equation by dx. So it's like cross-multiplying the dx. So we come up with dy is equal to cosine 2x dx. Okay? Next, we're going to substitute in for u. So we take this u, substitute it in for 2x, and this dx, we're going to take this du over 2 and substitute that in for dx. And so on the left we have dy is equal to cosine, and this time we say u, and times du over 2. Now what have we done here? We have been successful at getting the cosine of a single, in terms of a single variable, as opposed to 2x here. And now we can integrate both sides, and when we do that, take an integral symbol here, an integral symbol here. The left side is y, and the right side is, well, we have this 1/2 out front, and then we have the integral of cosine u. And I'm going to draw my little Santa Claus snow cone thing here. Or snow cone Santa Claus, that's how we say it, right? Minus minus. Integrating, we're going back this direction. So the integral of sine, of cosine, is going to be sine. So we have sine u and then we have our constant of integration c, which we always have to use for an indefinite integral. And then the last thing we're going to do is substitute back in for u. So we're going to take this 2x here and substitute it back in. for u. So we end up with y equals 1/2 sine of 2x plus c. Okay, so as you get familiar with these u substitutions, you may be able to get by without having to do this formal process. But be careful. It's easy to make mistakes. It's easy to end up multiplying by 2 when, as is in this case, you should be dividing by 2 or multiplying by 1/2. Next, the integral of 9 quantity x squared plus 3x plus 5 to the 8th power times quantity 2x plus 3 dx. And what you're looking for when you have the product of two polynomials in this case, you're trying to see if when you take the derivative of one, you'll end up being able to cancel by division another term here. So you see this 2x plus 3? So what I'm going to do is I'm going to let this whole thing inside here be equal to u. Okay, so I'm going to say let u equal x squared plus 3x plus 5. And then du equals 2x dx plus 3 dx. And then du, therefore, is equal to, we factor out the dx, so we have dx times 2x plus 3. And now, solving for dx, dx is equal to du over 2x plus 3. Okay, so let's substitute here. And using our u substitution, we have, it looks like 9 is a factor, a coefficient, so we can just take the 9 out front. And so we say we've let this be u, so we say it's going to be u to the 8th power, and then we have times 0.2x plus 3 times our du. We're going to du over 2x plus 3. We're going to replace the dx. So we're going to place here du over 2x plus 3. Now, what happens here? If we've done this right, we should get a cancellation to neaten things up a bit. So we're equal now to 9 times the integral of u to the 8th power du. And now, integrating, we have u to the 8 plus 1, which is 9, and we're dividing by 9. That makes that convenient, doesn't it? And then we have plus our constant of integration c. I'm just going to work to the right here. We have that. So we have u to the 9th power plus c. And that's going to be equal to, replacing back our u, it's going to be x squared plus 3x plus 5 to the 9th power plus c. And this is going to be our answer right here. Okay, let's go on to this last one in this set. We have the integral of sine squared 3x to cosine 3x. And sometimes you don't know exactly where these things are going to end up. I'm going to do a rewrite of this. This sine squared 3x, I'm going to rewrite this as sine 3x squared, because that's what sine squared 3x is. Cosine 3x dx. What I'm going to do is let u equal sine 3x. So let u equal sine of 3x. Now we differentiate, and we kind of have to go both ways here. So du is equal to cosine, the derivative of sine is cosine 3x times the derivative of the inside, which is 3. So we'll put this out here, times dx. So dividing, dx is equal to du over 3 cosine 3x. And now we can just go through here and make our u substitution. So we replace the sine 3x with u. So we have u squared. And then we have cosine 3x. And we'll replace this dx here, we're going to replace with du over 3 cosine 3x. So we have a nice cancellation here. And that's going to be equal to this 3 down in the denominator. We can bring this out front as 1/3 u squared du. And integrating, we have 1/3 u to the 3rd power divided by 3. Put 3 down here. And we have plus c. And what do we have here? 1/3 divided by 3 is 1/9. So we have 1/9 u cubed plus c. And replacing with u, with what we let that equal to already, we have 1/9 sine, and we have to the 3rd power, so sine cubed 3x. And we have a constant integration still, c. So that's what we have. I hope this has been helpful. We're going to use u substitution later with definite integrals also. Good luck, and thanks for viewing.